Welcome to a new test and teardown video. Another associated research ground bound tester. So a model 3130. This one is in a little bit of a sad condition. I think the plastic under here is cracked. Or at least this front is not taping so well anymore. Look at that corner. It went to the floor. So I bet there's something we need to look at inside this unit. So as far as I understand, this is a low voltage but very high current test system for testing ground connections, especially earth ground connections in your products. And it is able to supply up to 8 volts or 6 to 8 volts of AC, but it will be able to deliver 40 amps and then measure the voltage drop. And this way it can measure resistance in milliohms at a very high accuracy and also prove the ground connection is good for all that current. And this is required for a lot of high power equipment as a good indicator for safety. And this is the classic way they make test and reset. I'm so sad about this corner here. Also, there's another little problem. Opening all the boxes, poking around with all the test leads. See, again, that is test leads for the high voltage unit I tested the other day. And this is not compatible. Hang on. See, I also got all this. So another one of these, and then the end of that cable is again this high voltage stuff. It just don't fit. And the other one comes with 2 cables, and again for high voltage kind of stuff, right? So that just don't fit at all. And it also says high voltage, la 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 la, not that. And look at that. We also got those cables, and I believe that is actually for another ground bond tester. Not exactly this model, but for another similar model, because it uses exactly this high current connector here. And then there is a sense signal. So current goes in here, and then the sense, and then you can attach this to your test object, and then the positive again, the same kind of way. But this don't fit this unit. So why were they packed together with all this completely wrong test equipment? That means they either got wrong equipment or ordered wrong equipment or somehow mixed it up. See, this is a ground lead. This one fits that one. Interconnect. And what the heck is interconnect? All we care about is the current and the return. But there's no way this is... We really need a super special connector for this. Damn it. There's no... This is definitely not working in any possible way. Look at that. Hello? How do we do this? No, we cannot, right? So, sad. But I found this interconnect disable in the box for this one. And this is a different one compared to the... Oh, this unit is really, really heavy. Okay, there's a calibration. Aha! This is a calibration thing. So if you remove this, you can access calibration, interconnect, a return. And again, the same kind of thing. Signal input. Ooh. Oh, damn it, this is completely loose. This is probably how it is, right? So I should just try and connect. Oy, 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 oy. This can't be good. I better open before I power it up. I was hoping this was in a little bit better state compared to the other one. That was like brand new, but because this is a very useful instrument. Unfortunately, it's okay. Here is the voltage selector, and that is correct. It also says, "Ooh, be careful." La 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 la. Good. We'll do that. So now we're inside. This is really a beautiful unit again. They're using more or less the same chipsets. That's what I think here, right? Quite a lot of ICs and God knows what. I mean, this looks like a personal computer with all that kind of stuff. And handling the display and inputs and all that stuff. And then we've got some power supplies, and oh, that is a current sense that we really would like something, huh? Shunt. Oh, that is nice. And the mains transformer is huge. I mean, I can just only lift it like that. I'm not able to lift the entire unit in a stretched arm, but of course I'm just weak and old and sick, so that is of course, oh, yes I can. Look, and it says something here about something we should be aware of, but I already found out what we need to be aware of. Let me get a little bit more light. I don't know if you can see this, but I mean, there was a little kaboom here. Ugh. Also, if you look at the connectors, it's actually a sense signal in the sensor pin, and then the power is the outer metal of that connector type. But this unit is clearly blown up. Something bad happened here, and it sprayed all its guts and glory all over the place here. So, oy. And it's also here. It's probably also on that resistor. But you see here, that was a big boom. So I think it is really good that we didn't power it on, because there's definitely something wrong here we need to focus on. And we got this heatsink with full of transistors on both sides, so that's obviously the current source. Is that really how it is? Quite loose. I think it's really funny we see one fan in one end and the other fan in the other end. Really? Why is that necessary? But that's just the way they did it. But unfortunately this unit is completely blown up. I mean, we could just try and power it up and see if it's a little bit alive. But I would like to understand the origin of this smelly thingy here. Can't be the mains setting fuse. No, not really, can it? How is this possible? And there's, I think I have to open all this kind of stuff. I'm trying to understand the origin of the problem, because as I can see here, Look at that. It really looks like the cable burned quite a lot between those two. So how is that possible? Really? And you see how it's sprayed into the mains. Somebody also soldered the VDR. And look at the back side of that. Super long. Aha! Somebody tried to replace this. So that was the problem. This one is a replacement. Look at the soldering. It's super dodgy soldering. So somebody replaced. That is what blew up, right? And this one is obvious. Yes. This one is another type. So that is why this looks so burned. The VDR blew up. That is interesting. So maybe it is okay to power it up, because everything else here looks quite alright. I mean, this has nothing to do with the high current output or anything, because then it would have been the entire cable that would have been burned, right? And it's exactly those turns of the cable that is right next to where this would have been, the blown one. And see, the fan probably blew the smoke that way. So I think the rest is quite alright. I think I will try and power it up real slowly. They did actually repair this, but it's obviously not the most beautiful repair. Other than that, I mean, yeah, let's just go for it. I mean, this looks super beautiful here. Oh yeah, and by the way, I figured out this interconnect that is just directly connected to, as you can see here, the high power ground. Not the sense, but the high power ground. So, if that is any help. And that connector is indeed. Ooh, that can't be good. I need to have a look under here. Why don't we just try and power it up and see what happens, right? So I left the power switch on. I'm now using my variable supply and cranking up the voltage from 0 to see if there's any kind of... Oh, look at that. Why are we making so much noise? Okay, that was weird. So now we'll crank up the voltage to a 230 volt. And let's try again. 24, 23 volts of input current power usage. I mean, it's alive. 30 amp, 100 milliohms, la 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 la. Are you ready to try and test and see if it blows up? Interlock. I forgot to put on the interlock thingy. Hey, it works. Haha! I think we have a winner here. Let's see in a second. Ah! It stopped because there's an open. Look at that. Almost no amps, but then the resistance is way too high. So we need to short circuit the input, and that is a difficult task because look at those connectors. I don't know, but of course I could set down the menu X. Well, how do I change this? Menu. I am in the menu, right? System. Result system. Is that okay? Blah 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 blah. What do we do here? All sorts of things. Cal date, alert date, la 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 la. Where are we with the... here probably. No. Oh. That is how it is. So how do I change the... The software here isn't really that intuitive designed, but I think I figured it out actually. Look at that. Now I've set it for 1 amp and a maximum of 510 milliohms. That is the highest value it can accept as a pass test. And then you can go into the menu and then you can scroll through the different memories. This is memory 6, step 1. So we've got different steps in each setting. See, here we go, the different settings or the different memories, and here we got the different steps of memory 6. So this is the first step. This is where I'm at the moment. Then all you have to do is hit menu again, and then it's not that easy to understand, but test here means actually show all the different test parameters or edit your test setup, and then you can see the different settings here, and then you can go down here and change whatever you want to change, right? You can even change the test frequency from 50 Hertz edit plus 60 Hertz or 50 Hertz. So that means it's actually generating the test frequency on its own. It's not using the mains frequency, and that is exactly what I was thinking about that it's doing, but no, you can change that. And offset, connect, la la la, exit. So now the current is only 1 amp and a max of 500, so I think I do dare to try and stick in something here and try to short circuit this. I think I will try and make a resistor or connect a resistor of a known value that I know will handle 1 amp, and then we'll see if the unit actually works or if it just blows up the resistor. I don't know what you want to call this, what I just did here. Built my own connector. I think I got a pretty good connection, but because this is a 4-point test system where current flows only in the outer part of the connector, the high current part of it, and then this is of course the voltage difference sense point, right? I call this adapt, overcome and improvise, right? So this is a 2mm a threaded screw, and this is just a normal solid installation wire. So this resistor is 270 milliohms plus minus 10%, and I tried to mount the sense as close to the resistor as possible, so that means current flows here, and then I should be able to measure the voltage difference. It's of course this unit is definitely able to blow up this resistor if stuff is not doing its thing correctly here. So we should of course be aware there is a potential explosion danger here of this, but it's of course only 40 amps it can do, and only, I don't know, 6 or 8 volts. So I am in the same test program, 1 amp, 500 milliohms, and it should do this for 10 seconds. Yes, I set it for 10 seconds, so let's try and see what happens, okay? It is definitely testing. And this one is good. 281 milliohms. And then we're done. I mean, now I really would like to verify this actually happened. So how can I do that? I should be able to measure the test voltage here, then I know that it's actually pulling 1 amp through my resistor, and I should of course also verify the value of this resistor. So what if I turn this off? I mean, the unit should definitely disconnect this completely, right? So I just connect another ohm meter, and it reads 280, almost 281. So, oops, it just did. So, I mean, really? So that means this unit does indeed measure the correct resistance. All I need to do now is to verify that it's also testing with the correct current. So, I mean, if the resistor is 281 milliohms, I mean, it's real simple, isn't it? If we give this 1 amp, like that, why don't I measure any DC voltage? That is weird. It's because it's AC. I'm a big idiot. Hang on. Oh, I wanted to see if I could figure this out. Memory. Menu, right? And then test. And what I do now is I change the test current, edit, and then positive here. Just hold it in a little bit. Oopsie doopsie. Let's go for 5 amps. Oh, that is difficult to hit. Okay, like that. 5 amps, enter. Exit, exit, and then it shows real loud and clear what is the, and it's still the same resistor, and it is 1.4 volts. So far so good. And this is now, ooh, damn it, I got a shock. Yep, that is 7 watts. This is a 5 watt resistor, but if I'm only doing this for 10 seconds, I mean, it is still alright to touch. So, and this is why I didn't overdo the current. So yeah, I think this is really working quite well. I don't dare to crank up the current to its maximum potential because I don't have the correct connectors. I don't even know where to get exactly that type of connector. But if you do figure this out, you'll be able to run this unit up to 40 amps, I would assume. I can't give any guarantees because I'm not testing it any more than this. But so far, everybody has survived, and we didn't blow up anymore. But sure, this mains is turned off, and everything here is ice cold. Yeah, all is really great here. Oh, look at that mains transformer. This is just huge. Oh, look at that. Is an interesting detail. That screw is connected to chassis, right? And that piece of metal here is also connected to chassis. Look at that. Yeah, okay, I can actually see it. There is a hole in the chassis where the screw is. So the top of that screw is not touching the metal here. Otherwise, you could imagine what would happen. Also, look at that. bendy here. So this reveals this unit was indeed dropped on the floor. Someone was angry when the smoke went out of this one. I can probably fix this a little bit. But anyway, I'm not gonna bore you anymore with any more cool details from this unit. I think that was it. I hope to see you again tomorrow. Bye bye.